Our next speaker is a Senior DevOps Engineer at Wix with 15 years of experience in the tech industry. She's also a public speaker who believes that DevOps culture is what drives a company to perform at its best, and talks about it in DevOps infrastructure conferences. And she has a passion and a vision to enhance and drive business success by taking care of the infrastructure through automation and DevOps, of course. In her spare time, our speaker is a lead singer of a cover band, giving back to the community by co-organizing DevOps-related conferences. She's Hila Fish. Let's welcome her on stage. Okay. And she's going to be talking to us today about Terraform Practices, the good, the bad, and the ugly, which is a great movie I really enjoy. And a very nice song, actually, the introduction. So the floor is yours.
Thank you. Okay, so first of all, thank you so much for being here on your weekend, which is really none taken into granted. You're devoting your own time, so thank you for that. One disclaimer, I'm a bit recovering from a cold. I might cough at times. I will try to do it outside of the mic. So let's start. So first of all, let's talk about Terraform. And I will cover here things about Terraform in a broader context, not just bits and pieces regarding usage, Terraform usage, like usage and practices, but hopefully will make you think about Terraform in a broader context rather than just an infrastructure as code tool, so you'll be able to leverage it better for infrastructure scaling, team scaling, etc. So basically to open your mind about Terraform and not just think about it as infrastructure as code per se. So first of all, hi, my name is Hila Fish. I'm a senior DevOps engineer and I work for Wix. I have 15 years of experience in the tech industry. Recently, I've joined the AWS Community Builders Program, which allows me to connect with like-minded people and learn more about AWS in depth. I help organize conferences in Israel, where I live, DevOps Days Tel Aviv, and Statcraft Monitoring Conference. I'm a mentor in courses and communities. I'm a DevOps culture fan. I think this is what helps companies achieve great things. And as you can see in this picture, I'm a lead singer in a cover band, which is a lot of fun. Okay, so Terraform implementations can be sometimes good, bad, and also ugly. Some disclaimer about that. I'm showing mostly examples from AWS providers, but of course, Terraform works with all providers. And I'm talking about Terraform open source. Probably it gets implemented differently for cloud or enterprise, but I only worked with open source, so all things here have that in mind. So, quick wins. When I say quick wins, I mean things that you can achieve in a matter of minutes or a very short time to help you leverage Terraform in a good way. So first of all, versions lock, the same as you do for Python with the requirements txt or a package lock JSON, right? You can lock versions for Terraform as well, modules, providers, and Terraform itself. A version is basically what syntax is expected and the features that are inside. So this is how you lock the versions for all of this. And the thing about locking the provider modules, you can see from this meme by Anton Babenko, is pretty much a celeb for Terraform. You want to manage code, but sometimes Terraform AWS provider issues got in the way. So lock your provider versions, because that way at least you will deal with the devil that you know. So the good way about locking versions is to lock both modules, providers, and Terraform versions. The bad way is to lock in a way that will still allow breaking changes to occur if you lock to a minor version, for example. And the ugly thing is to have no versions lock whatsoever. You will have syntax issues. You will have a lot of things that will really make your life harder. The next thing that I want to cover here is tagging resources. So for me, and I hope that for you as well, it's a must implement practice, because it will allow you to track costs. It will allow you to track also projects. And if you will tag your resources, then your FinOps team will thank you for that. And if you don't have a FinOps team, congratulations, you're the FinOps team. So you need to think about tracking costs, tracking your projects, and that's why we tag resources. And we have also the provider AWS Default Tags feature, which allows you to tag resources in that level, AKA, I just set it once, and then all resources that are created through this provider just get it out of the bat, which is awesome. And a classic usage for that is a tag of managed by Terraform, so we know exactly which resources are managed by Terraform and which not. So the good thing is to tag everything that you can, use default tags, like I just explained, and use PR enforcement. So if someone doesn't add tags to the resources, then the PR will fail merge, and I will talk about it more in depth in a bit. The bad thing is to tag inconsistently, because as we know, consistency is key, and it will allow us to track better. And the ugly thing is to have tags no whatsoever, because again, no tracking costs, no ability to know what's going on, so try to avoid that. The last thing in the quick win section is remote state. So by default, Terraform works with local state, and it's making it hard for teams to scale, because that way, if everyone works locally, then there's no one source of truth, there's no backups. So always aim to have a setup for remote state. This is an example how you do it for S3 bucket in AWS. So the good thing is to have your state both remote and secured. Make sure it is backed up. You can enable S3 versioning, and make sure that Terraform state gets locked while you run Terraform apply, because you don't want to have any conflicts in the state. You can leverage DynamoDB for that. The bad and the ugly are pretty much the opposite. So local state, have the state remote but not secured or backed up, and not having the state getting locked when you run Terraform apply. Okay, now we talked about quick wins, right? Things that we do in a matter of, achieve in a matter of minutes or very short time. Now let's talk about second nature. Second nature are things that you should think about in your day-to-day when working with Terraform that will allow you to leverage it better and basically prepare you for both scaling and align to best practices. So first of all, using community modules versus creating them yourselves. So there's a saying, right, why reinvent the wheel? So if you have a certain need, then a lot of community models already have covered a lot of features of providers that you can just leverage and use them instead of creating the models yourself. And also another thing about community models, that they are proven over time, right, because a lot of people are using them, and they eliminate the need for you to maintain them because they do it for you. And also about community models, that they have checks. Usually they have checks to make sure that the code that gets entered to the model is in a high quality state, and I will show example for that in a bit as well. So the good thing is to use verified community models wherever possible, of course, because if it's not fit your use case, don't over push it. And when I say verified, I mean that recently Terraform, HashiCorp, the company that created Terraform, they removed the labels of verified from the models in the Terraform registry, so you don't know what is verified, but you can check the amount of downloads of each module, and then at least you will have some sort of indication that this module is widely used and probably is safe to use. The bad thing is to use a custom model of your own, but if you still maintain it as a community model, aka you have tests, you make sure that it is maintainable and consistent, then it's still quite okay. And to have a used community model without a version lock, then as I explained before, it could get messy. And the ugly is to have both custom model of your own and unmaintained. Don't have consistency, don't have checks, because then it could get out of hand and you wouldn't be able to use it widely. And use unverified community models, so it could potentially introduce malicious configuration in your environment, which is not that great, or at all. So if you do have to create your own models, just make sure to make them stateless and clean and generic as much as possible, and you do not repeat yourself if you don't have to, and the code is kept simple stupid, as they say, and you have practice enforcement to maintain the code quality. So as we have for community standards, you should do it for your internal models as well. And I know that I have this build-up towards practice enforcement. I will get to it in the end, don't worry. Okay, I want to go now to variables versus locals. So variables are pretty straightforward versus locals that are more, let's say, complex or allows complexity. And the values, the values of locals doesn't change between runs. So if you run Terraform apply, destroy, or plan, it's basically the same. And you should leverage it whenever you want to do something complex. So for example, in this example, I have a project and environment variables, and then I can have like a final state of tags using locals because I merge between the project environment and the required tags, which are different. And then I have a final definition, which I can use throughout my code. So on the module side, you should use variables as settings for a module configuration, but also always make sure you set up default or validation, because if not, then if someone uses this model, then the module will just get break if you haven't passed any value. And for locals on the module side, you should treat it like a constant to be honored or relied on. So for example, if I have a module to create an S3 bucket, then I can set up a naming convention that everyone that uses this module will have a naming convention for the bucket, which is awesome for us. As a company, we want to have naming conventions. We want to track all of our buckets. So we can achieve that by setting the naming convention in a local. And basically, everyone that you will use the module is bound to that, and this kind of bound is good. And just a small reference about this specific example. If you do stuff with naming convention and stuff like that, think about the cloud providers' limitations, like maybe they have characters limitations, so think about that before you do something with namings. So on the live side, and when I say live, I mean like, let's take, for example, if a module is a class in code, then live side is the instantiation of the class. So for the live side, if you use a variable once, so just set a default, and if you use it per region, etc., use a tfvars file, which you can reuse for all regions. And for locals, you should really avoid using locals in the live side because we should aim keeping the live side as simple as possible and leave the logic to the module side. And you should leverage data sources as well to grep, to get the dynamic configurations and then pass them to the modules, and that way you have, and you deal with the most updated information. Okay, so the good thing about variables and locals is basically to use tfvars where necessary, and you can also utilize environment variables because that way you don't need to compensate with another variables that you will add because you have like a built-in variables. Use locals to hardcode one-time names, decrease code repeatability, and try to keep things as much as generic as possible. The bad thing is that Terraform allows you to create multiple local blocks, so if you don't really have to do it, don't do it because then it's very hard to maintain it because maybe people will spread it out to different files and it will be hard to maintain. Decentralized vars basically from the same reason. You want to have one variables file, and I will cover it in a bit, so it will be easier to maintain. And ignoring environment variables, why? I mean, you can utilize them instead of compensate with more variables to maintain. And the ugly thing is to hardcode the vars values were not necessary because this is the meaning of variables, right? They need to vary. So if you don't really have to hardcode values, try to avoid it because maybe then later on you'll need to refactor stuff, and you should avoid that. Okay, let's move to file structure. So I hope that we know that Terraform executes all files that has the suffix of tf. But we should still have naming convention for our files, again, for us, for our ability to maintain the code. So we can take an example from the community standard, and this is what they have. They have main tf for the main logic, and then variables, data for data sources, and versions for all Terraform and modules, and not modules, providers versions. And also, if you have more peripheral stuff, you should break it down to files. So for example, if I have a module to create a VM, then I will put these resources in main TF, but then if I need to create a security group, I will put it in SG file. If I need to create a load balancer, I will put it in a different file as well. And that way, it's pretty much a logical breakdown that will help us do things in a clear manner and maintain the code better. And for modules, if you create a complex module, consider breaking it down to submodules, because that way you gain two things. First of all, you can reuse these submodules in other parts of the code, and then reusability is one of code best practices. And also, if you break it down, then you don't have a gigantic variable file, and then it's just bound to the relevant portion of the module, and it's easier to maintain it that way. And you can also take example from a community about that. We have the community module for EKS, which has a submodule of creation of the node pools, and also VPC module has a submodule of VPC endpoint. So we have this example, and we should follow it for a better management of the code. Okay. So this part I really, really like, because you say it's about applying classic code best practices on Terraform. And you can say, wait, but Terraform is not a pure programming language. So what's the relation between classic code best practices and Terraform? So yeah, I don't think that anyone thinks that Terraform is a pure programming language, but concepts of code practices still apply on Terraform, and we can see an example for that from HashiCorp that introduced the ability to loop over models only from after version Terraform 0.13. So beforehand, you couldn't loop over models, and since the release of that version, you could. So that's why even HashiCorp realized that we need to have classic code best practices applied on Terraform as well, and that's why we need to keep a Terraform in source control management, GitHub, GitLab, whatever you choose. Keep the code simple as much as possible. Do not repeat yourself if you don't have to. Even principles of functional programming can be applied on Terraform, and make sure the code is idempotent. And in regards to human and clean, I want to say something about, just make it check in the time. Okay. I want to say something about, I want to quote something from an article, a great article. I will have a reference for that in a reference slide at the end. A great article by Thyssen Uhr. He said, and I totally agree, that the computer that executes the code doesn't care if the variables are ambiguous or vague, right? If the syntax is correct, then it just executes the code, and that's it. But we need to have clarity. We need to have cleanliness of the code and naming conventions and all of these things for the sake of us human beings, because we need to maintain the code. We need to not, curse the other person that left the company and left us this ambiguous code and say, what are we doing here? We need to make sure everything is clean and readable for us human beings and for the sake of us and not the sake of computers. So please try to incorporate as much as classic code best practices on Terraform as well, because it will help you in the long run. Okay, so we covered quick wins, right? Things that you can achieve in a very short time. We covered second nature, which are day-to-day awareness for working with Terraform. Now let's talk about the long haul. And the long haul is basically the thing that you should plan ahead when you work with Terraform. That will help you utilize it in the best way possible, if for isolation of environments, if for I'm just trying not to look at my notes because it's so far away. Basically do whatever necessary to utilize it in the best way possible when you plan ahead. So before I will start this section, I want to ask you this question. How do you envision the infrastructure and the company's needs? Because this is a very important question that should lead you not only when you work with Terraform, but working with anything that you do during your projects, because you need to do what's best for the infrastructure and the company's needs and use cases. I want to give you an example about that from work. So not a while ago, I had a daily sync at work. My job is to be in the DevOps team for the data engineering group. And we have a tool called Presto, which is basically a tool to query data. And currently, Presto is installed on a fleet of machines, autoscaled by autoscaling group. And on one of the daily syncs, someone from the team suggested, let's move to Kubernetes. And then all my team members, yeah, let's move to Kubernetes. Yeah, let's do it. Yeah, we want to do it. Yes, that's awesome. And then, between me and myself, I thought, okay, I also want to move to Kubernetes because it's a great tool. I like troubleshooting, so there's that. And it will help me in my career because a lot of companies adopt or already adopted Kubernetes. And if I will work with it more, it will be best for my career. And there's no such thing as enough experience with Kubernetes. It's very complex. So as long as I will work with it more and more, it will be beneficial for my career, and I will able to provide more value to my next employer. But I didn't say all of that. I stopped all of this, and I didn't think about myself. I thought about the application itself. And what did I actually say? I said, okay, I understand, but let's think about maybe Presto is not suitable for Kubernetes. Maybe it's not ready yet. Maybe the maintainers of Presto say that it's not ready for Kubernetes. Maybe people are not using it in production yet, and maybe it's not still in a ready enough state. So that's the thing. Buzzwords are really nice, but we need to avoid them and do what's best for our infrastructure and the company's needs. And that's why I want to show you what we do in Wix for structuring the Terraform codebase, because we planned ahead. We thought of our needs that we need to scale both infrastructure and our teams. And that's why we figured out this structure that I think that will make sense to you as well if you care about infrastructure and teams scaling. So let's see the structure that we have. It started with team, and then project, cloud provider, and region. And to emphasize that, so we have the live and the models, and then BI for team, Airflow for project, AWS for cloud provider, and US East 1 for region. And why did we select this structure? Two main reasons. First of all, Terraform as a platform. Okay, so I don't know if you know, Wix is very, very, very big, and we have a lot of teams using Terraform, and we wanted to have like a baseline that everyone will use Terraform in a certain way, aka we have the practices enforcement to make sure the code is in a high quality state, that everyone can reuse modules and just use them to their best ability and not create them themselves because they don't know something else is already there. So we have one Terraform code base in GitHub, and all teams in the company is using that. So whenever a new team wants to onboard to this code base, they just create a new folder, and basically that's that. They get out-of-the-box models from the models folder, and also we are leveraging GitHub's code owners file so they can approve their own PRs, which is awesome. So they also have the autonomy to do whatever they want in their folder. So that way, we achieve autonomy, we achieve the out-of-the-box models that they can use, and we achieve the ability to make sure the code is in a high-quality state because the practices enforcement, which I will get to it very, very soon, I promise you, applies on the entire code base. So this is one reason why we did it. Another reason why we did it is to have small state files set up. So I don't know if you know, but Terraform creates a dependency tree. So whenever you create resources, Terraform knows by itself that if you want to create a VM, of course, the VPC that you created needs to be created first, and then the VM will be in that VPC. So it creates a dependency tree, and sometimes the dependencies that Terraform creates are not that great. So we need to help Terraform do its job better. And to do that, this structure works perfectly because, as you can see, the state file is kept in US East 1 level, in the lower level, which means the state file consists only of Airflow resources of BI team in AWS US East 1, which is awesome. So that way, if the state files are small, then we eliminate the big blast radius. We eliminate the possibility of invalid dependencies, which is great. I worked with huge state files where I just added the tag, and then Terraform plan showed it's gonna destroy a resource. I'm like, why? I just added the tag. So it could happen, and we need to help Terraform do its job properly. So small state files will help you achieve that. Now I want to move to Workspaces. It is another thing that Terraform offers, so let's cover that. So Workspaces is basically an isolation of code. So if you have the same Terraform config, you can create different workspaces, and then the state files is only for that workspace. So it's isolated from any other workspaces. So it's good when it's the same Terraform config and different customers. So let's take an example from GCP now. So each customer is a GCP project, and each customer is basically a different workspace. Coupled with that, let's say all customers need to use the same service, like financial service or login service in different regions. Then they can just use that, and we put these services also in workspaces, and that's basically it. But we need to note some things about workspaces as well. So we should consider using a Terraform wrapper when we work with workspaces to avoid human errors. Why is that? Because how do you work with Terraform workspaces? With CLI. Terraform workspace select X. If I forgot to do this select, production incident. So try to avoid that and have a Terraform wrapper. You can create a mini system with Python that handles the changing of the workspaces for you, and basically that's that. Another thing is that you have less visibility. Even if you do use the Terraform workspace conditional, it doesn't mean that all workspaces that you have available are actually in use. Maybe someone created a workspace and it's not really in use, and and you don't know what to do with that. So you should really think about all of these when you decide going down this path of using workspaces. Another thing, workspaces, that I want to read you something from the Terraform documentation. Sorry about that. Okay, so Terraform documentation say, use workspaces to manage multiple non-overlapping groups of resources with the same configuration, which means and suggests that you can use it for multiple environments, right? Dev, staging, production, multiple regions or locations, and multiple accounts, like I showed in my previous example. But also, from another portion of the documentation, they say that multiple deployments of the same infrastructure, serving different development stages, staging versus production, named workspaces are not a suitable isolation mechanism for this scenario. So I don't know, in my entire career, I never had the same infrastructure serving both dev and production. I'm not sure if this is what they meant or not, but if it raised a question for me, maybe it will raise it for you as well. So just take all of these into consideration when you think about going with workspaces. And at least we can think about and agree on one classic usage of a workspace is that it could serve as a side branch. So if you want to test out syntax or a set of a new infrastructure that you're going to create, you can create a new workspace, like a side branch, test it out. If all looks good, then you apply it on the production environment, which is the default workspace. So the good thing about really planning ahead when you are structuring your Terraform codebase is that it will allow you to have small states set up and to set up a Terraform as a platform, which is awesome when you need to scale both teams and infrastructure. The bad thing is that organizational changes could require you to restructure the code if you didn't plan ahead, and who wants that, right? We want to have control of our code, and we need to decide whenever we restructure it or refactor it or not, and to use workspaces for the wrong reasons, as I just showed you. And the ugly thing is that really, if you don't plan ahead, if you don't structure the code base in a way that will have small states but huge state files, then I can guarantee you will have invalid dependencies, big blast radius, and it's really very, very hard to maintain Terraform and the infrastructure in this way, because then you will need to start dealing with applying with the target, and it's very complicated. So try always to aim to have small states set up. Okay, let's go to Terraform execution. So we should aim to have execution of Terraform which is remote. And why is that? Because we want to have one source of truth. We want to have a mechanism that handles the locking for us, right? And not tell our like a team member, wait, I'm running Terraform, so wait a minute, right? It's too manual. We need to have something that handles it for us. So do a remote execution. I can share what we do in Wix. We have, we're leveraging an open source tool called Atlantis, which is an open source tool for Terraform pull request automation. So whenever I open a PR, then what happens in the background, Atlantis runs Terraform plan. I see the plan, I see that everything is okay, and then I run Atlantis apply. Then when I do this, after I check the plan, of course, the output, two things happen. Both the code gets merged to main, and also the merged to main, and of course applied. And this guarantees two things, that both Atlantis handling the Terraform state lock, so if someone just in the same second try to run Terraform apply on the same code that I'm running on, then it will say, sorry, I'm locking it, and actually have a link to the PR that locks the state. And also, that way, we make sure that the main branch equals the actual environment. So that's about Terraform execution and why it should be remote. You should also apply Terraform with a plan file. Atlantis does it for us, but if you run locally, just do with the -- plan file, because that way you know exactly what are you applying. And set up Terraform timeout, because at some point I applied Terraform when I had, I created an auto-scaling group with spot instances, and the price wasn't right. And then I had to wait and wait and wait. So in order to not wait, just set up Terraform timeout that is reasonable for you. The ugly thing is to execute locally, because then you will need local configurations, local credentials, and you don't have audit on whatever you're applying. And the ugly thing is to execute locally and run Ctrl-C when you run Terraform apply. I did it when I just started out with Terraform, and it messed up my state. I don't know if they fixed it by now or not, but I don't want to find out. So just try to avoid it, because especially if you don't have backups for the state, then it will get messed up, and it's very, very hard to recover from it. Okay, we reached the section that I had this build up throughout the presentation, practices enforcement. So what is basically practices enforcement? It means that we can have tests set up on the code level to make sure any practices are being applied. So it could be practices to make sure the code is readable, to make sure resources are tagged like we do in Wix, to make sure the code is reusable and clean. And these practices enforcement are being done on community models, which I will show in a bit. But you need to bear in mind that these are good not only to make sure general guidelines apply, like that the code is readable and reusable, but also specific guidelines for your needs. So for example, if you're a small company, or you know that your developers are very big spenders, then you can set up checks to make sure that if infra cost is more than $10,000, it will alert certain people. It will alert the FinOps team. So you can really, the sky's the limit. You can set up any guidelines that you want to make sure it is applied, and also to make sure that the code that gets entered to the code base is in a high quality state. And I'm going to show an example from a community model right now. So this is from Terraform AWS Autoscaling. So you can see that we have tests here to make sure the contributor formatted the code with Terraform FMT, added documentation, and write a working code with TFLint. And by the way, TFLint doesn't only check syntax to make sure the code works, but also checks best practices, like if you forgot to add a version to the model, it will shout on that. So that's awesome, and I really recommend setting these up, because it will help you maintain the code better in the long run and with less ability to really be on top of that, because the developer will just see it, and the PR will fail to merge because of these tests not being successfully run. So the good thing is to have pre-merged linters, formatters, and logical checks. You can do it with GitHub Actions. You can do it like we do in Wix. You can do it with CI pipeline checks, whatever makes sense to you. You can create a Slackbot drift reporter to detect any drifts between the main branch and the actual environment, or you can do what we do in Wix with Atlantis, which basically eliminates it. Because if you don't run locally, you only run remotely, then whenever Atlantis runs, it applies and merge to main, and then make sure the main equals the actual environment, which is awesome. The bad and ugly here is not about practices enforcement. It's basically about what happens if you don't have practices enforcement in place. So you could face security issues, and you could face also non-compliant configuration being introduced to your code base. And on the right, I've put some tools that will help you in your journey of introducing practices on your day-to-day. So you could leverage them, and basically these are pretty awesome, and all open source. Okay, so I asked you this question before, right? I want to ask you this again, because I couldn't stress enough how this question is important. I heard a lot of stories about, yeah, we didn't plan ahead, and then we need to restructure, and we need to refactor and stuff. So before you jump the gun, plan ahead, think things through, and it will help you utilize both Terraform and any other tool or thing that you do at work in the best way possible that will fit your specific use cases and pain points. And I'm not sure if this is big enough. You tell me. But this is the main key takeaways that I want you to take out of this presentation, because I covered a lot of things about tagging, about remote state, and a lot of things, but these are the practices that will help you in your day-to-day to make sure that you can scale better without growing pains, to make sure that you do things in the best way possible for the sake of the company. So think about your code base structure to have Terraform set up as a platform and to have small states files, and have practices enforcements being implemented, because that way you will enable infrastructure and team scaling, and basically help others help you maintain Terraform as a platform. And I want to finish with another quote from Thyssen Uo's article, which I will have reference in just a bit. He said that programs evolve and code changes, right? And if everyone will write Terraform in the same way, right, then I wouldn't even be standing here talking about Terraform practices. Everyone would just write the code the same way, continue with our lives, and that's it. But this is not how projects work. We always want to introduce projects to our environment, and in order to do that, we need to think about utilizing things in a way that will allow projects to get introduced. Because what is a project? It's a way for the company to improve, because moving from one state to the next desired state is a project. So in order to allow projects to get introduced, we need to think about use cases, we need to think about Terraform limitations, we need to think about how we want to do things, and then combine it all together to make sure it is implemented, and we don't do stuff only in an ad hoc manner, but really plan ahead and think about things and how to achieve that for our company's success, and eventually, of course, our success as well. These are the references that I mentioned throughout the presentation. So some links about tagging, Workspaces, the Thyssen Uo blog post, which is really great. And Superlinter is a bundle of GitHub, like a bundle of checks that you can add to the practice enforcement, and that way you can have out-of-the-box great tests that you can add to the practice enforcement journey. That's it. I hope that you enjoyed, and I think that we have time for questions, maybe. So that's it. Thank you.
Hila Fish, everyone. Thank you so much. Very interesting conversation and concepts that you mentioned. Having worked many years in the IT operations, I know the challenge, and to be able to achieve operational performance and consistency. So I guess infrastructure as a code is key. And as you said, it's very important, from the beginning to architect it the right way so that you can go ahead and not have to go back and make changes that are painful. So I guess I can ask the first question. Did you actually choose Terraform when you got 2 weeks, or it was already there?
Yeah, it's already there.
But do you think it's the best tool out there right now for IAC, infrastructure as a code?
It's again, it's really dependable on the use cases. So for example, if you work in a company where all people are developers and not really people that know or want or have the time to learn a new syntax of HCL, the Terraform syntax, then maybe you should leverage Pulumi, which is a tool that allows you to create infrastructure and write the code in any language that you want. So you should really think about your use cases and what you need, and just.
But at the same time, I guess the fact that it's cloud agnostic, it's an open source tool,
Right.
so that's a big advantage
Exactly.
also. And it has features that I guess make it a leader currently in the market. That I guess brings it up front as
Right.
one of the best tools to have, even for a young new team in DevOps
Exactly.
team
I
that
use
they're looking
Terraform.
into.
I use Terraform both in Wix, which is a very large company, but also in a startup.
Yeah.
It was great for both cases, but that's the case. Even if you're a startup, and I forgot to say it because I didn't look at my notes,
Okay.
even if you're a startup, you need to think about scale, and you don't have to do things now, but there are things that you can still prepare and structure it in a way that will allow you to scale without losing too much time on the now. Like, you still be able to focus on the current projects, but but if you still structure it in a way that will allow you to both scale and serve the now, then it's the best solution possible, because it will save you a lot of growing pains in the long run.
I understand. Very well, so that's great. Let's see questions. So we have the first one here. It says, in test VMware with TerraTest, can you have a sufficient test of your resources instead of validation?
I actually haven't used VMware
Okay.
provider. I only use the cloud, so I don't know, but need to test it out and see.
Yeah. Okay. The other one is, what is your opinion of Terraform CDK? Yeah.
I haven't used it myself. I know other programmers that prefer it because it's more code-oriented than
Yes.
Terraform. From their experience that they shared, they said it's quite okay. It is complex, so you need to know what you're doing. But once you do and you leverage it properly, then it is a sufficient way to work with.
Great. Any more questions? Do we have something more? I guess that's it. We're closing. Since you are a singer, and we share, the same passion as Southeastern Mediterranean cultures, I was wondering, do you know any Greek songs?
Drink songs, wow.
No.
Only the ones from the movies.
Okay.
But nothing from my culture, no.
Okay. Would you like to sing something for our audience here? You see?
I can assure you this is the first time I'm doing it on stage when I'm on a conference. This is the first time. I have a gig quite soon, so I can take one of the songs. In your house, I long to be, room by room, patiently I wait for you there, like a stone. I wait for you there, alone, alone.
Wow. Yeah.
Thank you.
I think you're in the wrong business, to be honest with you. But we really appreciate being here today and also singing to us.
Yeah, I mean,
Well, we really,
I can guarantee
you can tell that the Greek audience loves you, and we share the same passion for music as you do.
and I
it's
can
clear.
guarantee you this is a conference I will remember for life. So thank you for sure.
Great, thank you so much.